All right, we're doing the happy number question. This is question 202 in LeetCode. So what's going on here is you are given a singular value and you're checking if when you break those numbers up continuously, right? Square them, add them to one another, that over time it's A going to equal to 1, which if so, you want to return true. Or if it's not equal to 1, then it's a cycle. And if it's a cycle, then you want to return false, right? So, given the idea and kind of breaking down the problem, it has already highlighted here if the loop um, is endlessly in a cycle and does not include 1, you want to return false, right? So it's a cycle, right? If it's a cycle, then you're thinking of Floyd's algorithm, right? Which is what I mentioned earlier, like yesterday or 2 days ago. Um, when doing that, you A, need to run a while loop, and then B, um, that's going to have to be a whole separate function, right? So what this problem is looking like is you're probably going to have to break this out into two functions. Um, one which is going to check if it is a cycle, right? If so, return false. If not, return true. And then B, which is breaking down those numbers, right? And then actually like finding the happy number. So let's get started. So the first thing is I'll create another function called happy underscore number, right? And we'll just pass in an argument x. And then within here, the goal of this function is to check if it's a happy number. So we could do that by doing slow fast equals n. Remember in order to check if a cycle is going on, you are going to have to use, which I mentioned, Floyd's algorithm, which is slow and fast, right? That one is going to go 2 times the speed, while the other one is going to go the normal speed. If it is a cycle, they ultimately will end up equaling one another, right? And then you're going to do while true, right? Because I mentioned you need a while loop. You are going to do slow equals and fast equals. And then you're going to initiate the function and pop slow in here. And you're going to initiate this function twice because you're going 2 times the speed. You're going to pass fast in there. There you go, right? And then what's going to happen after this is you're going to need to run some if statements. If if fast, because this is going to be first, if fast equals 1, return true. Else if fast equals slow at any given time, then we want to return false. There you go. All right. And then for this function, this is creating the happy number, right? So what that you're going to do is we're going to have to create current equals 0, and then we could do while x is greater than 0, right? We are going to create a digit, which is going to equal x remainder 10. So what this does is basically grabs the last number, right? And then once we grab that last number, because we're going to be messing with digit, we're going to want to remove it from x. So x divide by 10. And then what this does is removes that last number from the overall value, right? And then what we could do is current plus equal current plus equal digit squared, right? Perfect. And then we will just return current once this is done. And I think with that, it should work. So what's going on here is that we have slow and fast, which in this instance, let's say n equals 19, right? The equal 19. So let's go and loop through slow first, right? Because slow is just going once, going normal speed. So we're passing in 19. Slow equals this method with 19 as an argument, right? Okay. So 19 is x now, right? We set a like a placeholder value, right? Placeholder value. And then while x is greater than 0, while 19 is greater than 0, right, you're going to first grab digit, or create a variable called digit, and set that to x remainder time. So what this does is literally grabs 9, right? It grabs the last number. So if this was 120, this would be 0, right? Or if this was 14, this would be 4, right? In this instance, it's 19, so digit equals 9, right? And what this does is, remember, x equals 19. This literally removes the last number from the overall value. So instead of it being 19 now, because we're removing the last number, it's 1. X equals 1 now, right? If it was 34, x would equal 3, and digit would equal 4, right? So with that being said, now what we're going to do is just grab the current, which is, we're going to set it equal to digit squared and squaring it. So for this instance, if this is 19, this is 9. 9 squared is 81, so current equals 81, right? Perfect. But is x greater than 0 still? Yes, because x is 1, right? It was 19, we removed 9, right? So now x is 1, so we do this again, right? So digit, this grabs the last number. If it's just one number, like for instance, instead of 19, it's now equal to 1, there's the last number is 1, right? So digit equals 1. And what this does now, when there's literally nothing else, this now turns it into 0, right? Okay, so digit equals 1, x equals 0, right? And then current equals digit squared, right? So remember how we stored current as 81? So it's 81 plus digit squared. Digit is 1 right now. 1 squared, 1 times 1 is 1. So 81 plus 1 is 82, right? And we're going to check, is x greater than 0? No, because this line right here made it 0. So this is one iteration. It's a lot. This is one iteration, right? So now fast or slow equals 81. For the sake of time, we'll look here. So you could see how slow equals 82. And then for step 2, right, fast does it twice. So it's, it's the same premise, it's the same value. So you're going to 82 just like how we did. But then you're going to plug 82 back into it. So instead of 19 being x, 82 equals x now. And you can kind of see here, you get the 8, you get the 2, you square it, you add it up to one another. 82 squared is 64, 2 squared is 4, you get 68, right? So fast now equals 68, and slow equals 82. So now we go back and check the if statements, right? Because we just ran these two lines. If fast equals 1, well, fast doesn't equal 1, right? It's not one, not close. And then fast equals slow, no. So we haven't reached any of these conditions yet. So because of that, we're just going to run this function again with the new values that we're given. So if slow equals 82, right, we're just going to plug 82 here, right? Because remember, the argument here is slow. So we're going to just do this again with 82 being our x, right? And we're going to do fast again with 68 being in. So you can kind of scroll down and check the second loop, right? 82, this is 68. We obviously know this because we got this value in the first iteration. And then this does it twice, right? So you could see 68 is 100, right? And then we do it one more time because we're doing it 2 times the speed. 100 back into that function. We break it down and it equals 1. So fast equals 1, right? So now we have fast equals 1 and slow equals 68. We go back to check the conditions. If fast equals 1, return true. This passes, right? So this condition is valid. So we return true and we break, right? Perfect, perfect, perfect. And then if I was to initiate this, right? So all right, so looking back into it, it was a super quick fix. I just had to add self here. The reason for that is because without it, we don't really know what the number is, right? We don't know what the happy number is, but when we do, it basically is telling the code to look into the object, to look into the method we have, and to grab the current value so we can continuously do it, right? So that's why I had self here, here, and here. Um, but once you do that, you just initialize solution equals solution, right? You call it a class. Result is going to equal solution dot is happy. We're just calling this function right here because we want to just return if it's true or false. Print it, and then boom, it's true.